Hello and welcome to Learn Data. It's great to have you on the channel. I'm Nilesh and today we are going to continue learn about pandas. In this video we'll learn about pivot, stack and unstack. So why do we rotate or flip or pivot rows to columns or columns to rows, and then we'll look at some examples in Jupyter Notebook. So what is the reason that we need to convert certain rows to columns or convert some columns to rows? Why do we do that? And the reason is it depends on what we are trying to look at. For example, in this table we can see there are 4 columns: month, week, brand and the amount of rice sold. And here, as we can see, the month is listed in row form. Now if there is a need to see that how much of the rice was sold total for each month, then we could do aggregate sum, such as the one shown on the right hand side here. That's one need where we could use this type of pivoting. Another situation is shown in this table where we move the weeks to from rows to columns, as you can see here. And what we are trying to do here is we are ignoring the column brand and just looking at the columns month, week and rice sold, and putting it in a new format so that we can clearly see how much rice was sold in the month of January, February, in the weeks of first week, second week and third week, irrespective of the brand. And that's when we would flip or rotate rows to columns. And here, the table on the right, we can think of those as stacked rows or stacked data set. And this is commonly seen if you have a time series and timestamps of certain activities. So all the data would be recorded in a stack of activities at each time point. And if you need to look at the data set in a different way, such as here, then you have to pivot it, or basically you want to convert the rows to columns to be able to put it in a new arrangement that is easier to analyze. Furthermore, in the previous slide we saw that we turned or flipped only the one column which was week. In this particular video we are doing that, but then we are still keeping the brand column in there. And what this gives us is a new type of arrangement of data where we have, for month of January, we can now see what brand sold how much, and wherever there was nothing sold for that brand, we can see that there is NaN value listed, as we can see here. Here we can also see that for February, for each of the brands, what values were sold. And again, so here we can think of the table on the left hand side as a stacked data frame or stack table, and on the right hand side we can think of this as unstacked. And this is a simple example. There could be more than one levels here on the column side as well as on the row side. So there could be multiple indices where month could be considered index one index, brand could be considered second index on this axis, and similarly there could be one index week here on the columns, and there could be another index here on top of that, which would be above the weeks. Okay, let's go to Jupyter Notebook and see what we have today. I've already gone ahead and imported the 3 libraries: NumPy, Pandas and matplotlib.pyplot. And this time for data we have couple of different data frames that I've created already. And the reason is because we are going to look at different situations, and therefore there was a need to have very specific data in each of those data frames, so we could not use the same data frame for all these situations. The first data frame is a data frame which is 4 columns. As you can see, 2 columns are month and day. We probably are going to use those as indices later on. This second column, second data frame, is 2 levels. So here we have this rain, wind, and then stone, river. Those are 2 levels of indices that we are going to work with. And next we have the third data frame, which is a simple data frame, but then I'm going to show you how we can use this data frame to see how sorting happens when stacking and unstacking a data frame. Next we have this data frame df4, where it's multi-level indexing again, but this is now 3 levels of indices. We have this level, this, and this. There are 3 levels of indices. And then after that we have again this particular data frame df5, which has 2 levels of indices, as you can see here. But then here we are going to look at a different combination, and I'll explain that when we are working on this particular data frame. Finally, this example is quite similar to the first one, except that these sets of month and week that are listed here, they are in a different arrangement that will allow us to do aggregates later on. I know there's a lot of data, so you may have to pause the video to be able to write down all the data. So I'm going to keep it like this. So this is df1, this is df2, df3, df4, df5, and df6. Now in each of these data frames, before we move on, just want to show you how the indexing work. We haven't talked about multi-index indices before, and here what we are doing is creating a tuple, which is a list of zipped objects. So we have 3 lists in there, 1, 2, and 3. So what zip will do is it will put together the tree, plant, rain in one tuple, and that tree, plant, rain would be 3 levels of indices for 1 row. Okay, and so on and so forth. So when we run these, we would be able to see those. So if we look at df4, here as you can see, tree, plant, rain, that is 1 index. So if you look at the indices for df4, this is what we are going to work with: tree, plant, and rain. So that's that. And again there is a second index. So these are 3 levels of indices here, and we just have 2 columns. Okay, now let's start with pivot and how we can use pivot to kind of move the columns around and rows around. df is equal to, for this we are going to use the data frame df1, and what df1 has, it has 4 columns: month, day, and then columns a and b. Here what we are going to do is we are going to keep the column of month as is, but then we are going to convert the column of day into columns. So what I mean by that is, right now the day column has data in different rows: Monday, Wednesday, Thursday. So we are going to create columns of Monday, Wednesday, and Thursday, and so on, for the data that's in the day column. To do that, we want to write df is equal to df1.pivot index is equal to month, and index is what we are going to leave as is as a column. Then columns is equal to, these are what are going to appear as column names, So the contents of the column day are going to appear as separate columns, and that's why we have columns. And values, so here we need to pick a column that has values, so we'll pick column A, which has the numeric values. Now when we run this, we get a pivoted data frame of the original data frame, where we still have the month column as we had before. It has December, January, March, the months are there. However, the big change is we dropped column B because we did not use it here. We just looked for A, and then the day column has Monday, Wednesday, Thursday, and we converted those into individual column names. So the corresponding values from column A are shifted within this particular grid. For example, if we look at this, December Mondays has a value of 7 for A. So December Monday has a value of 7 for A, and December month does not have any other days, so therefore those are listed here as NANs. Similarly, the month of January and March, we have this data listed here. Now you're probably wondering what happens if we do not give these values here, or if we give all the values. So in that case, we get sections of these. So let me show you how that works. When we run this, here we get a section for column A. So this column A and column B are treated separately, and for each of those we get the pivoted Monday, Tuesday, Thursday and Wednesday, as we can see here. And for each of these we get these values listed for the months column. Now the interesting part in this particular output data frame is that we can pick what we need from this. So let's say if we are interested in only the values for B, then we can choose that, and now we have this subset data frame from this pivoted data frame which has values for only B. Okay, let's now look at how stack and unstack work. So stack and unstack. So here we are going to use our data frame df2. Now in this data frame, let's look at what the indices are. We have the index rain, stone. So rain, stone. So these are indices. The weather and geology, those two columns that we see on the left hand side, those are index columns, and the actual data columns would be the day, time, harvest and seed. So here if we go ahead and stack these, so df is equal to df2 dot stack df, we get a Pandas series back, which has, what it has done is it has collapsed these three columns into a single column, which is as we see here, and then the values corresponding to each of these columns are put here in this single column. Now if you look at the type, if you look at the, let me create some cells here. If you look at the type of df, it's a Pandas series, as you can see. So here in this case, if we look at the indices, you can see that now we have three levels of indices: rain, stone and then day, which we pulled from here, and now that's a separate index column in itself. Okay, so we have three levels of indices right here. What we can now do is we can go ahead and unstack these. So I'm going to delete that and then go back here. If we say df.unstack, what this does is it will take the stacked data frame or stacked series that we had here and then convert it back to what we had before. Sorry, df2. As you can see, this is, although the orders are sorted here as compared to original data frame, but it's the same data. We have the 4 columns: date, time, harvest, seed, and then we have the index columns: weather, geology. Now you're probably wondering what happens if we pick and choose, like what happens if we pick just weather, or what happens if we pick just geology for stacking and unstacking. Does that work? Yes, that does work. So why don't we do one thing? So here we'll continue to use the df that we have stacked, and now if we try df dot unstack 0, so what 0 is doing is we are unstacking, that is we are converting these rows to columns. So we have rain and wind, so we converted that weather index column to actual columns, so column names. So here we have rain, so that's now converted here to columns, and now the data frame looks like this. Okay, similarly, if we move one level in, so this was 0, if we move one level into geology, which is 1, let's see what happens. So if we do df dot unstack, this will now unstack, as in convert stone, river to a separate column, and that's what we get. Stone and river are converted to a separate column. The weather index stays as is for rain and wind, but then the grid is arranged in a different way, where we have all this data for all the days, time, and harvest seed, and then but it's divided between the river and stone. Moreover, if we go one step further, and if we try df dot unstack 2, in this case what we are doing is, this is level 0, this is level 1, this is level 2. So when we go to level 2, we are basically going back to where we started. So we are converting all those items in that particular column to an individual separate column name with their individual data in those columns, as we can see here. Now what we have been doing is unstacking by number, like level of stack. We can also go ahead and use unstack by name. So if we try df dot unstack, and here if we say geology, then we get the geology index column converted to actual column names, and the data is distributed accordingly, as we can see here. So we had the geology here, which had columns which had the data stone and river, and those now are separate columns, as we can see. Now we've already looked at the sorting, but let's pull the example that was specially created to see that. So sorting during stack unstack, we are going to use the column data frame df3, and as you can see in this data frame we have 3 which is appears first, 1 appears in the next, and then 9 appears before 0. So if we try to stack this or unstack it, and now if we stack this back, just df stack, here we can see now that as compared to the original column, original data frame, which was this one, we now have a sorted data frame where 1 appears first, 3 appears next, and the 0 appears before 9. So that's just to show you that during the stack unstack procedure, the data in the data frame is sorted. Now let's move on and look at a new example, and here we are going to use different levels for stack and unstack. And the data frame that we'll use is df4. Here, as you can see, there are 3 different levels. We have the forest, farm, and weather. 3 levels of indices for the rows, and we have A and B as column names. To double check, we can, if we look at df4.index, here we can see that we do have 3 levels of indices which are named here. Now what we can do is we can pick which particular level we want. We can, previously we have seen that we were able to choose one level, but now we'll see if we can choose more than one level at the same time to do the stacking and unstacking. So let's do that. Df is equal to df4 dot unstack, and here we will choose the levels by name, and we'll choose farm, and then the second one we can choose is weather. Now as you can see here, what we would expect when we were unstacking this is we are putting whatever data is in these 2 index columns as separate individual columns and column names. So we would expect there to be a separate column for rain, cloud, and a separate column within those for plant and soil. So we have plant, soil, and we also have, there is a fruit also. So we have plant, soil, fruit, and then within that we have rain, cloud for all of those. And that has been done for each of the original columns A and original column B. So we have column A that now has another layer of index, and then below that there is another layer of index. Now the row indices are limited to just 2 trees and leaves, so we just have leaves and trees here. So data is now shifted from a vertical format to a horizontal format, and wherever the data is not available, those appear as NaNs. For example, in column A, plant with rain, leaves, so leaves does not have plant, so it just has soil and fruit. Therefore anything other than that, it is blank for the weather that's there. Now if we can go ahead and unstack this, so let's try that. Df dot we can stack this. So df dot stack and level is equal to farm and weather. Now when we run this, we get the original data frame back that we started for unstacking. And you're probably wondering what is the use of doing all this stacking and unstacking. The reason is because sometimes when you are dealing with data sets, you'll probably encounter data sets that are like this, where let's say you have some of the data sets that I've seen are you have the names of the customers listed in rows, and then on the columns there could be channels of TV, and within each channel what are the programs they watch. So A could be a channel name, and then within that these could be day. On Monday, which is they watch these 2 episodes, and Tuesday they watch these 2 episodes. So if you want to aggregate the data in that form, it sometimes can become difficult, and therefore the stacking and unstacking kind of helps solve that problem. Now let's move on to another example where we are going to take a subset of the existing multi-indexed data frame. And for this we are going to use a data frame df5. So df5 data frame, in the previous data frames what we have seen is only the row index had levels, but here we have levels for both the row index as well as column index. If we look at df5.index, we have 2 levels for the rows, which are transparent and frequency transport, and then if we look at dot columns, here again we have 2 levels for the columns. So it's a multi-indexed column as well as rows. I'm gonna go ahead and delete these two. So if we were to take a subset of this data set, we can randomly pick a couple numbers. Let's say df5.alloc, and the reason why we are using alloc is because we are going to use the subsetting by index numbers. So 0, 2, and maybe 5, 4, maybe 7. And if you do df on this, so here as we can see we got a subset. So look at 0. So 0 is 25, so we got that row 25. 2 is 0, 1, 2, so we have this 18, concrete one way 18, so on and so forth. So we get this set of rows based on the indices that we provided here. Now what we can do is we can do the stacking based on the index for column as well, and let's see how we can do that. It's the same syntax. We can say df is equal to df5 dot stack, and let's try fuel, and when we run this, here we get, so here now we get a new data frame where previously we had this as columns, but now we did the stack, and what that did was it moved these from columns to rows, and therefore after that we would be left with only one row of index for column names. However, we are adding one additional column of index for rows. So we previously just had these two, now we have transport, frequency as well as fuel added here, and the values within the data frame are arranged here accordingly. Okay, so this is what we can get when we stack a column, set of column indices. Now we can go one step further and say df is equal to df5 dot stack, say vehicle. Now in this case what we did was, previous case we stacked the fuel index. This time we are stacking the vehicle index. So for vehicle, we leave the fuel column names as is, and we shift the vehicle index from columns to rows, as we can see here, and the data gets sorted and rearranged in the grid that we can see. Further, we can also get subset from the index for rows as well, rows and columns both. So previously we just took a subset of rows, now we can get subset of columns. Let's try that. So df is equal to df5 dot alloc, and the method is the same. First we are going to give the index for rows, and then we are going to give the index for the columns. And we run this. Now we have just these two data points. Previously, let's look at the original one, df5. So here, as you can see, we had couple different index numbers, so 0, 1, 2, 3, but we just picked 0 and 1. So therefore we just have this column and this column, car and truck, and 25, 12, 25 and 12. So we picked just these two columns, and we picked rows 0, 2 and 3. So 0 would be this first one, then 2 would be this 18, and then 3 would be this 17, 27. That's what we see here. Okay. Now with this column as well, we can bring this one and do the unstacking for this one. So if we do the unstack, sorry about that. Okay, now when we did the unstack for this one, what we are essentially doing is we are keeping this last or 0 index as is and moving all of these as columns. So when we do that, the point that I wanted to show is if there is data, we see it here. For example, tar road, one way, car petrol, it's 25. Tar road, one way, car and petrol, it's 25. But then for two way, there's no data, because tar road does not have any two way. So therefore it appears as NaN in both car and truck. Okay. So that the NaNs are taken care of automatically when we do the stacking and unstacking. Now moving on, when we started this video, we saw the pivot command. Now we'll look at a variation of that, which is pivot table. Pivot underscore table, and this command is helpful because we can do aggregations with this command, and it's similar to the output we could get from Excel pivot that we can do. And the data frame that we are going to use is this, which is showing month, week, and the quantity of sugar sold and quantity of salt that was sold in each of those months and weeks. Now for the regular, let's first try and use pivot and see what problems we run into. So if we say df is equal to df6 dot pivot, and as before we can give the index, month, and we can give the columns, and column, let's keep week as the column, and then values we can pick the sugar sold column. Now if we run this, it's going to give us an error, because what pivot is expecting is that the month column and the index and columns here, these two have unique combinations, but here we have January 1st repeating 3 times, and therefore it probably does not know which of these values it wants us to weave it wants us to pick, and therefore when we run this we get an error. It contains duplicate entries, cannot reshape. Okay, so that's the reason. And to solve this problem we can use the pivot underscore table command, and when we run this we get a consolidated version of the original data frame that we see here. Now what's happened here is this particular default setting, we got the mean values for the data that's in here, and to check that we can actually go ahead and add the aggregate function here. So we can say, so here we can say aggregate function is equal to np.mean, and when we run this, that's exactly the data points that we have in here. So the pivot table is really helpful to aggregate the data if there are duplicate entries, or if if there are reoccurrences of same data points for different time points maybe, then we can aggregate them together and get a sum total, or we can do other type of statistic on there. So if we want sum, we can get sum as well. So as you can see, we can see it sum. I think we could get also standard deviation if you wanted. Yes. So this really helps, and we'll look into the statistical part of it later in other videos in more detail. But that's what I wanted to show you all in this video, how pivot works, how stacking and unstacking works, and I'll be posting some exercises also in a few weeks, so you'll get hands-on experience in using these in such an special situations where these come in really handy. I hope you learned something new today. If you are still confused, I suggest going back and running through the video again and kind of really trying to understand what each of these functions are actually doing. If you have any comments or suggestions, please post them in the comment section below. Please like, share and subscribe. I will see you all in the next video. Thank you.